Okay, no cycle is formed. The next minimum is 4. So only 1 is there. So this is number 4. The next minimum is 6. Okay, the next minimum is 6. 6 is this one, from 2 to 3. But if you pick 6, it will be making one cycle. If you see, if I do this, it will be a closed path. That means cycle has been formed. So you have to ignore this edge. The next minimum is 7. No, 7 is not there because this is 6, this is 3, this is 1, this is 2. Sorry. So this one is not there. This value is not there basically. Okay, this value is not there. So all the vertex have been included, and this is the minimum spanning tree having the minimum cost attached with it. If we would have selected the different one edge, so the spanning tree might have changed. For example, there the first edge as 1 we have selected 1 to 2, but 1 having here also. So we could have selected this also. Number 3. To 4. We could have selected this. Then 2 again. We have this and we have this. We have picked this, maybe this time we are picking this. Till now no cycle is there. Then next is 3. That time we had picked this, we can pick this also. We can pick this also because till now there is no cycle. So here also you thought that there could be number of minimum spanning tree in a graph. So there is no rule that there is only one spanning tree. There will be number of spanning. There might be number of spanning trees. Then the next minimum is 1, 2, 3. Then 4. 4 is alone. So now see, here we cannot pick this 4 because it is giving the cycle. Then the next is 6. So 6 is 2 to 3. Yeah, 2 to 3 also if we will take, so it will form a cycle. So we have to pick the vertex also. This also we have to pick. Then yeah, 1 to 2 minimum, because all the vertex must be there. So 1 to 2, because this is not we are going to pick because it will create the cycle. So 1. So this is one of minimum spanning tree. Another spanning tree also can become if we will take another option. So this is how the Kruskal algorithm will work. Kruskal will form the spanning tree edge by edge. Now another approach is taken by the Prim's algorithm. Okay. So we'll take one example again. Okay, how the prims work? Prims will work, it will take one starting vertex. Any of the vertex can be chosen as any arbitrary vertex basically can be chosen as the starting vertex. For example, we are taking 1 as the starting vertex. After picking the starting vertex, we are going to pick the edge that has the minimum value. Minimum edge we will pick, and accordingly vertex will be chosen. So if we see here, there are two edges from 1 to 2 and 1 to 2 and 1 to 3. Minimum cost having 1 to 2. Okay, and here also we will make one. This is 6 and maybe for example this is 3. So 1 to 2, from 1 I have 3 now. From 1 I have 3 edges, 1 to 2, 1 to 3 and 1 to 4. Out of this 3, 2 and 3, which is minimum? 2. So we are going to pick this as the edge in our spanning tree. Now we will see from the 2 which are the minimum. from 2 which are the edges, and then we will pick which is the minimum. So from 2, 1 is so 2 to 1 already we have taken. Then we have 2 to 3 and 2 to 4 and 2 to 5. So which one is minimum? 2 to 4. This is minimum. So this is minimum. Now from 4. From 4 we have again 1, 2, 3, 4. 4 edges are there. 4, 1, 6, this is 3. 4, 1, 3, 6. So which is minimum? 1. Already we have taken. Okay. Then it is already taken. So next minimum is the 3. This is 3. No. Yeah, this is 3. That is 6. That is 6. No, and that is 4. So we can pick here. One, 3, 4, 6. So next is this 4. Out of 3, we cannot pick any because it is going to put the cycle. Okay. And then we are going to take 5 minimum. So this is the minimum spanning tree given by the Prim's algorithm. So once again we will check how we are approaching. We will picking one arbitrary vertex as the starting vertex. For example, 1 we have taken as the starting vertex. From 1 I have 1, 2, 3 edges, out of which 2 is minimum. So I have taken 2. Okay. Next is the this edge vertex 2. From 2 I have 1, 2, that is basically 3 value. This is 3 value. So 2, 3, 1, 5. So which one is the minimum? That is the 1. So we have taken 1. Next is the 4. From 4 we have 4, 6, 1, 6. 1 already has gone, so we will take as the 4. Okay. So that is giving me the vertex number 3. Next is the from 3 I have these edges 3, this 3, this 4. But we cannot take because it will give a cycle. This also, yeah, this also will form a cycle. Then the remaining vertex is the 5. So 5 we will take, and which edge from the 5 is minimum, that will be chosen. So from vertex 2, because it has only 2 edges, 5 and 6, so 5 is minimum, we will pick 5. So this is what the Prim's algorithm will give as the minimum cost spanning tree. So this is how Prim's algorithm and the Kruskals algorithm find out the minimum spanning tree. And this is the greedy approach because every time we are picking the minimum edge, every time how we are picking the vertex or the edge, the minimum concept we are taking here, and every time the edge that is giving me the minimum value, we are picking that one. The difference between Prim's and Kruskal is that Kruskal firstly identify all the edges and then it will pick the minimum edge, and from by edge it is going to pick. Okay. In Prim's we are going to take first vertex. Any vertex can be taken as the first vertex, and from that vertex we are finding which are the edges attached. Okay, and out of those we are picking the minimum, and then whichever edge is coming, according to the vertex the next vertex will come. And from that vertex, now again we will check how many edges are there, and then we will pick minimum. So like that. So this is Prim's and the Kruskals algorithm. So this is the Prince-Kruskal gradient approach. Thank you very much. In the next class, we will see the dynamic programming approach. Thank you.